Welcome to Java Fundamentals for Android, Part 2. In this video, we're going to be talking about objects, classes, and methods. So this video is probably one of the more theory-heavy videos out there, but bear with me and we'll get our heads wrapped around this. Conceptually, Android and iPhone apps are essentially made up of a collection of objects that send messages and interact with one another. What are objects? Objects are combinations of data and procedures. Programmers group related functionality into objects so that you have a segregation of duties. You'll have one object that's responsible for fetching data from the internet. You have another object that's responsible for drawing things on screen. Each object handles a specific part of the program. So what do I mean when I talk about objects being a combination of data and procedures? Imagine we have a car object. The data or the properties of the car are the information it contains. It's the horsepower it's got, it's the number of doors that it's got, but the procedures or the behavior are the things that it does, like drive. To give you an example, in Android, we have button objects, and buttons have properties like visibility or positions, but they also have behavior or procedures like recognizing taps or clicks. Objects are created from a template, and that template is called a class. For a car object, the class is a blueprint that specifies how to assemble the car and what it can do. So creating an object would look something like this. Car, my first car, equals new car. And the keyword here is new. Let's take a closer look at this. In green, we have the variable type, which is, in this case, car, because we have a car object. Then we have the variable name, my first car. We have the new keyword, which is part of the Java vocabulary. And then we have something called the constructor. And what the constructor does is make a car for us, and it returns this car, which we're then storing in the variable myFirstCar. Let's delve into the car class. The first line reads public class car. So here we're declaring the class. Then it reads private int number of doors, private int max speed. These are the variables that are inside the car class, and because they're inside of the car class, they're called member variables, and they hold information about the car. And down below, we've got the constructor. This is what is called when we're creating a new car object from the blueprint, from the class. And in this case, we're assigning the value 4 to the number of doors, and we're assigning the value 120 to the member variable max speed. And what you notice is that the constructor has the same name as the class. It's not very interesting to have a constructor that just assigns a fixed number to number of doors and max speed. Some cars are faster than others, and others are smaller than others. So what we really want is we want our constructor to be able to take information in and use that information to assign it to those member variables. So in this case, we have our constructor have two arguments. And the first argument is an integer called speed. And the second argument is an integer called doors. And what's happening now is that we're assigning the value of doors to the variable number of doors, and we're assigning the value of speed to the variable max speed. That means we can create very different types of cars using this constructor. We can create an F1 car with a speed of 300 and no doors. We can also create a sedan with a speed of 140 and 5 doors. Now that we've talked a little bit about properties, let's talk about behavior. And for behavior, we need methods. A method is nothing other than a group of statements inside a block of code surrounded by curly braces. And the method has a name. So in this case, we have a method called how fast does it go? And the important thing is that for this method to be part of the car class, it has to be inside of it. So it has to be inside the last curly brace of the class. If we look at this method in a bit more detail, we see the following. Public int how fast does it go is the first line. Int is the return type of the method. Int is the type of the thing that the method spits out when it's finished. So this method returns an integer. How fast does it go is the name of the method. And then we have the curly braces. Inside the curly braces, we've got one statement, return max speed. So this method only does one thing. It gives us back the value of the member variable max speed. The thing that's important here is that the type of max speed is an integer, which matches the return type of the method, which is also an integer. Many methods are called to get some information back. If we have a method that multiplies two numbers, then we give it the numbers that we need to multiply, and we get back the product. But in Java, each method needs to declare explicitly what type of thing it returns. If the method doesn't actually return anything, if it just executes a bunch of statements that do something, and it's not giving us anything back, then we have to actually specify that with the keyword void. Therefore, every method has a return type, even if that method isn't returning anything. Can you spot the difference between the constructor and the method? So firstly, the constructor has the same name as the class, but also the constructor has no return type. Calling a method is easy. All we need is an object. So in this case, our object is the F1 car that we've created, and we call the method how fast does it go, putting the dot operator between the name of the object and the name of the method. And that's it. In this example, we're storing the value of max speed, which is returned by how fast does it go, in a new variable called F1 trivia. Just like the constructor we saw earlier, some methods take arguments. Suppose we've got a new method called pimp my ride, and it takes one argument, an integer called speed boost. This method takes the max speed and adds to it the value that we're supplying to it and the argument, and then it returns to us the new max speed, the increased max speed. For example, we can store the maximum speed of the sedan by calling how fast does it go on the sedan object in a variable called old max speed. And because we've created the sedan with a max speed of 140, old max speed will be holding the value 140. If we call the method pimp my ride on the sedan and supply to it the number 100, then the value that's going to be stored in new max speed will be 240, because 140 plus 100 will be 240. One thing I haven't mentioned so far were the public and private keywords that we've had lurking around in the code. So public and private are something called access modifiers, and these determine visibility. Now, what does that mean? It means that things that are declared private are things that are hidden, things that we don't want other parts of the program to see. And the fields that are declared public are the parts of the class which we want other parts of the app to interact with. Suppose we've got another method in our car class, and that method is called useABS, but useABS is declared private. Now we can use it inside the car class because it's internal to it, and we can call it in the break method. So the break method can call useABS, but we can't call useABS outside of the car class. For example, if we have another class called roadtrip, and in this class we are creating a new car, a Ferrari, speed 250, 3 seats, we can make the Ferrari brake. We can call brake on Ferrari, no problem, because brake was declared public inside the car class. However, we can't call useABS on the Ferrari object inside roadtrip because useABS is internal to car and we've declared it private. So why are access modifiers important? It has to do with how programmers group related functionality into classes. Each class will be responsible for something specific, and an app is nothing else than a collection of classes. One class will be responsible for drawing things on screen, another class will be responsible for fetching information from the database. But we don't want a class that's responsible for drawing to know the details of another class that's responsible for interacting with the database. And the reason for this is that sometimes we need to make changes to parts of our program, and we can only be sure that we won't be affecting another part of the app if the things that we're changing are private, because we're sure they're not being used anywhere else. So in summary, objects are combinations of data and procedures. A class is a blueprint for an object. The constructor is the thing that creates an object. A method is a group of statements that can be referred to by name. Methods always have a return type. If the method doesn't return anything, then the return type is void. And private methods and variables are only visible inside a class. Thanks for watching. In the next episode, we're going to be talking about logic, if-else structures, and loops.